How do astronomers know if there's water on a planet light years away? Wait, actually, how do they know what stars are actually made of? The answer is spectroscopy. Spectroscopy is the study of how light interacts with matter. When light hits atoms, electrons can absorb that energy and jump up to a higher level, or drop back down and release that energy in the form of light. Because every element's electrons have their own set of energy levels, the light they absorb or release make a unique pattern, kind of like a fingerprint made of light. By reading these fingerprints, we can determine the chemical makeup of an object. What's amazing is that this works from every scale, from the tiniest atom in a lab to entire planets and stars in space, all just by looking at it. When light passes through a prism or a diffraction grating, it spreads into a rainbow spectrum. You've seen this before. The rainbow on your floor caused by the way the sun hits the window. But it's more than the colors we see. Each element shows its own barcode-like lines, called spectra. We've tested this on Earth with single atoms and molecules, and telescopes use the exact same principle in space. Hubble can see visible UV and infrared light, while the James Webb Telescope specializes in infrared, letting us study planets and galaxies billions of years away. Knowing the unique spectra of elements, scientists can look at the spectral lines shifting or stretching to determine the speed of a star, how far away it is, and even its temperature. And by seeing which wavelengths are missing or dimmed in a planet's atmosphere, astronomers can detect chemicals like water or oxygen without ever leaving Earth. Spectroscopy allows us to study the cosmos by ironically focusing on the smallest level. In fact, we wouldn't even have discovered helium because astronomers noticed an unknown spectral line around a solar eclipse. So whether detecting water or other chemicals on distant planets, spectroscopy so far has let us figure out the composition of everything, from single atoms in a lab to entire stars and planets, all by analyzing their light.